Hello student, you have already studied about linear regression machine learning algorithm in the theory, PowerPoint. Now let's move on to the coding part. So implementing linear regression using Python, I'll be using Google Colab, and in this video I'm gonna show you like how to perform linear regression machine learning algorithm in Python using Google Colab. So let's start. Open Google Colab. We're gonna use this new Python 3 notebook. And let's give the name it as a linear regression algorithm. Yeah, that's it. So this is Google Colab we're gonna use, and so Google Colab we are using a Python 3, and now we are going to use a data set consisting of head size and human brain of different people. All right. Let's import our dataset %matplotlib and line by percentage matplotlib inline, import numpy as np, import panda as pd, import matplotlib.pyplot as plt. Okay, and plt dot rc params. This is for the parameter size of the figure dot fig size is equal to 20.0, 10.0. Yeah, so that's it. Just executing the cell to check. Oh, there is little error. There's an error, no module named panda. Okay, let's do pandas. That was an error. Yeah, so here we go. Let's use the another cell. This is to upload data. Okay, so we are uploading data. Yesterday one student asked me like how to upload CSV file in Google Colab. So here we're gonna show by using this from google.colab import files and uploaded is equal to files.upload. Okay, so this is the line code to upload the files. Here you choose file, head brain. This is the data set we are gonna use, and it is saving the file. So you see 100% done. You can see your files from here. So you see headbrain.csv file is available to use. So that was related to file upload. So you have done with the file upload. Now next is read data. Okay, so next we will import our data. We gonna read our data and store it into the data variable, and we will see how it works. So here you see the data. So here you can see the output. Our data set consists of 237 rows and 4 columns. Okay, so here you can see this. We have column as a gender, age range, head size in centimeter cube here, and the brain weight in grams. What we need to do with respect of linear regression algorithm, we need to find linear relationship between the head size and the brain weight. So now what we will do, we will collect x and y. Okay, so x would consist of the head size values and the y would consist of the brain weight values. So collecting x and y, let's clear this output again. Yeah, so here is collecting x and y, executing this, it's done. Okay, so x would consist of the head size values and y would consist brain weight values. So collecting x and y by this way, and let's move to the next. Now next what we will do, we need to find values of b1 and b0, or you can say m and c with respect of linear regression algorithm. So we will need the mean of x and y values. So first of all, we will be doing what we'll be doing. We will calculate the mean of x and y. So mean underscore x np. You can see mean underscore x is equal to np dot mean of x, and mean underscore y is equal to np mean np dot mean of y. Okay, so there's a mean x. Mean is predefined function of numpy. See this mean, you can see. So this is the predefined, and what it will return? It will return mean values to you. Okay, and the next what we're gonna do, we will check total number of values. So here you see m is equal to len of x, that's a length. Okay, so that it gives you total number of values. All right, and then we will use the formula to calculate the values of b1 and b0, or you can say m and c. Okay, m and c. If you are familiar with the linear regression algorithm, you know the m. Yeah, I'm just writing here just to understand a little bit. So what you can see is like y is equal to mx plus c. This is the formula. What is this? This is the coefficient formula that we needed. Okay, so what we need c, we need m, and we would be having x and y. Okay, so we are in the need of m and c, so we will be using b1 and b0 as a variable name, but that would be the value of m and c. Okay, so let's execute this one. This is what the code, and this is what the formula is. Yeah, here you can show. Oh yeah, so as you can see here on the screen, we have got b1 and b0. So the value of b1 we got is 0.263, and value of b0 is a 325.57. We have a coefficient, so comparing with it with the equation y is equal to mx plus c, as I mentioned, you can say the brain weight is equal to 0.263. Okay, so here let me write something for you. B1 is a brain weight as per our data set. Okay, so this is x, you can say. Okay, x we are using here, so we are not going to use, we cannot use x here as a part of equation. And b0, you can see what is b0 here. So the this brain weight, which is a b1, is 0.263, and multiplied by with the head size. So what is head size here is a C. Okay, so head size is a B0, which is a C. So here you can say as per formula of linear regression, this is X and this is C. Okay, with respect of performing formula like Y X and C to perform Y is equal to mx plus C. Okay, so you have X and you C. So X is a brain weight and C is a head size. Okay, and you have this coefficient value. All right. Yeah, so this is our linear model. Now let's plot it and see it graphically. Hmm. Execute this part. And here you can see. Okay. So this is how our plot looks like, and this model looks good, but we need to find it that how our model is, how accurate our model is. So in order to find it, there are many methods like root mean square method, the coefficient of determination, or R square method. In this video, I'll show you by calculating R square value. Okay, so let's calculate R square value. Let me clear this output just for instance. And yeah, you can see by executing this code. So SS underscore T, what is this? It is the total sum of square. Let's write it here. So that would be, it's a total sum of square. And what is SSR here? It is the total sum of square of residuals. Fine. And as you can see, R square formula here, okay, it's a 1 minus total sum of squares upon total sum of square of residuals. Okay, so this is the formula of R square. Okay, so let me write it here. And by executing, I mean we already executed this, so you can see this is 0.6393, kind of like 639. So 0.639 is our model accuracy. Okay, not accuracy, but we can say the value of R square. Okay, so what is this 639? This is the value of R square. Okay, so when you can see the value of R square is 0.69, which is pretty good now. So now that you have implemented simple linear regression model using least square method, and you can use, you can use scikit-learn to implement the same thing by very less line of code. So let's move on and see how we can implement the model using machine learning library called scikit-learn. Okay, so scikit-learn is the simple machine learning library in Python, building machine learning model, and that is very easy using scikit-learn. So suppose there is a Python code. Okay, so by using the scikit-learn libraries, your code is shortened in very less line. Okay, you can shorten your code. Let's write the code here. So here is the entire code by using a scikit-learn. Okay, so here you can see this is, and this is the code that you have written. I mean, we have written here, this is starting from here up to write this much, this is the line of code. And here you can see this is by using a scikit-learn. Okay, now let's execute this. So you can see what's the value of the output, r2 square, r2 underscore score. Okay, so r2 score, you can see it's similar to this. Okay, so here is r2 score you got, and here is r2 score you got. The both are similar, but this is by using scikit-learn, and the previous code, this is what you are seeing here, we have written, that's by using list square method. Okay, so here you can see by checking the output graphically and also checking the value of your model. This is R square value of your linear regression algorithm. Keep one thing in your mind, that whenever you are performing linear regression, you have to check your model. Okay, why you need to check your model? You need to check that whether your linear model is good or not. And R square formula, or you can say this list square method or scikit-learn method, you can use to calculate this R square value, which is 0.639. And by seeing this R square value, you can see your model is pretty good or not. Okay, yeah, so this is what all about the linear regression algorithm in Python using Google Colab. You can go through it. I'm sharing this code with you just for your reference. And if you have any questions, you can get back to me on the Blackboard, or you can email me. Thank you.